Welcome to Module 4, Lesson 5. Today we're going to relate decimal multiplication to fractions. So there's a lot of things that we already know, we're just putting them together in a slightly different way. Let's start with an example of 5 times 0.7. Now you know, if you can remember, that another way to refer to 0.7 is to say that it's 7/10. So I can change this to 5 and 7/10. And we've learned how to multiply when we've got a whole number and a fraction. We simply multiply across. If it makes you feel more comfortable, I will put a denominator under this whole number here. 5 times 7 is 35. 1 times 10 is 10. So I've got 35/10. 35/10. Check out that laser pointer. Now I know that the way to write that as a decimal is I write 35 and then I think about tenths. Tenths I know have how many decimal places? 1, that's right. So I'm going to put my decimal right here. I can see I've got in the tenths place of 5 and my whole number is 3. 35/10 right here. Easy peasy lemon squeezy, no? All right, please read this problem along with me. A Boy Scout has a length of rope measuring 0.7 meters. He uses 2/10, oops, typo, 2/10 of the rope to tie a knot at one end. How many meters of rope are in the knot? Well, I always say let's start with some sort of picture to help us understand it. Okay, let's say here's his rope. How long is the rope? Well, it says that it is 0.7 meters long, so let's label that. 0.7 meters. I could put in a 0 there if I want. Okay. Then what does he do with it? He ties a knot at one end. So here's he's got the rope. Now it's got a knot in it. How many meters of rope are in the knot? So this knot section, we don't know how many meters it is. What do we know about the knot? That he uses 2/10 of the rope, so not 2/10 of a meter, 2/10 of the rope to tie a knot at one end. I feel a tape diagram coming on. I don't know about you guys. So here's my rope. Imagine that this is divided into tenths of its total. Let's see if I'm clever enough to do that. There, do we have 10? I think we do. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Great, so we've got this whole length we know is 0.7 meters, and we've divided it up into tenths. He's going to use 1/2, it tells us, to tie the knot. Okay. So the question is, how many meters of rope are in the knot? So what are the meters here? 2/10 of the whole thing is 0.7 meters. Okay. Shift that away for a minute. So let's go ahead and do some multiplication. 2/10 of means times 0.7 meters. But I know that I can change this 0.7 into a nice fraction. What would that fraction look like? Yep, 7/10. Okay, I'm going to multiply across, and I get 14/100. Okay, now the important, I did something crazy to make that go away. We'll write it again. 14/100. Now I know that I can go, put that away. I can write that as 14. And hundredths have how many decimal places? That's right, 2. And I could also think of it this way. 2/10 times 7/10. I've got 1 decimal place in this factor, 1 in this factor. So in my product, I do need to have 2 decimal places. So my final answer is that there are 14/100 meters of rope in the not. Well done, team. Okay, now before we go, let's just look at a couple more examples. What if I had 3 2/10 times 2 1/10? Let's estimate this before we do it. Let's think about this number, 3 2/10. Well, it's really not that much more than 3. Then let's think about this number, 2 1/10. Well, that's barely more than 2. So 3 times 2 is 6. My product should be somewhere around 6. Now ask yourself, will it be more than 6 or less than 6? Yeah, if you said more, you're onto something, because this is more than 3 and this is more than 2. My answer is going to have to be a bit more than 6, but 6 is a good estimate. So now let's try actually doing it. We could, of course, change these to fractions, but I think now that we've figured out that cool trick that the number of decimal places is what matters, I don't think we need to actually turn it into fractions. Let's just try it with the decimals. Okay. 1 times 2 is, of course, 2. 1 times 3 is 3. 2 times 2 is 4. 2 times 3 is 6. Kind of running out of space here. 2, 7, 6. Now some of you are going to go, oh look, I lined up this decimal, I'm just going to bring that down. No! Don't do that, because we're multiplying. That means I count decimal places, 1 in this factor, 1 in this factor. How many in my product? If you said 2, you are a smart cookie, and there we go. 6.72. Now, how does that compare to my estimate? Well, it's pretty close. I said that my real answer should be more than my estimate, and indeed it is. 6 72/100. Let's do another one. Oh, I didn't really mean to send my title away, but I guess it has to. Messy, messy, messy. All right, let's try this one. It's going to be really similar. Let's remember that 3.2 times 2.1 equals 6.72, because now we're going to do 3.2 times 0.44. Would anybody like to predict how many decimal places we're going to have? If you said 3, you're onto something. 4. Okay. So 4 times 2 is 8. 4 times 3 is 12. The 0, remember, says that I'm moving on to the next place, that I'm now treating this as just the number 4, but really it's 4/10, which is 10 times bigger than this guy, so I had to put in that 0. 4 times 2, again, is 8. 4 times 3, again, is 12. I don't need to do anything with that 0. Add it. Carry the 1 for 1. Now, am I done? Is that my answer? No. Because if I had estimated, which I really should have done, this is close to 3. And this is, woof, that's like less than a half. Well, 3 times 1/2 multiply across is 3, 2. If I divide that, get a mixed number, I'll have 1.5. So my answer has got to be something close to 1.5, but because this is less than a half, it's not going to be exact. Something around here. This is more than 3. This is less, so it's going to be around here. So let's see. Back here, we've got 1 decimal place, 2 decimal places. That means in my product, I need 1, 2, 3 decimal places. So my answer is 1.408. Is that close to 1.5? Well, it's 1 4/10. 4/10 reduces to 2/5. 1/2, well, 1/2 would be 5/10. So it's pretty close. Yay. All right, I think you're ready to tackle the practice set. Just remember what you know about multiplying fractions, and remember that however many decimal places are in your factors, meaning all your factors, that's how many you're going to have in your product.